Hello students, hello and welcome to this video on permutation and combinations. We will solve 10 more problems on permutation and combination in this video. First we will solve question number 487, 488 and 490. In the last video I was not able to explain that how the solution of 487, 488 and 490 came. So the symbols I was not able to recall. Now we will do that, and the link to download the PDF will be in description. Also at the end I will show you my website from where you can download the PDF so that you can maintain an updated copy. And I will show you my question answer website which I have created for you. So first we look at these symbols. Where do they come from? Okay. So the symbols come from the occupancy problem section. All right. So we have distinguishable ball and distinguishable boxes. We have a formula which I used. Then you have the symbol S here. Okay. So this symbol comes from the section of distinguishable balls and identical boxes. And then we have P symbol Pn is from identical balls and identical boxes. So if you look at the problems, they are fairly trivial in that sense. Okay, if you understand those symbols, I will actually bypass the explanation. I expect you to understand this and try to solve it on your own. If you have problems trying to do 487, 488, let me know and I'll explain you more. That is why I have not updated the PDF with the explanation of symbol, because those are given in the theory. So what happened that I wrote this probably 2 years ago and then I forgot. You see that I'm not the regular student or teacher, so it is very easy for me to forget. After doing this algebra, I did trigonometry book, and right now I'm doing trigonometry, so it's no surprise that I forgot that. So with that out of the way, let's start with question 491. 491 says that 10 identical balls are to be distributed in 5 different boxes kept in a row and labeled. There should not be V, A, B, C, D and E. Find the number of ways in which the balls can be distributed in the boxes if no two adjacent boxes remain empty. So case 1 is when no box is empty. Number of ways of distributing balls is 9C4, that is 126. When one box is empty, number of ways is collection of one box multiplied by distribution of 10 balls into 4 boxes. That is 5C1 multiplied by 9C3, that is 420. When 2 boxes are empty, number of ways is selection of 2 boxes minus adjacent boxes. This should be, there is a backslash missing. Backslash times distribution of 10 balls into 3 boxes. 5C2 minus 4 multiplied by 9C2, that is 216. Case 4 is when 3 boxes are empty. There is only one way to select 3 boxes when adjacent boxes are not empty. So number of ways is 1 multiplied by 9C1, that is 9. So total number of ways is 771. Question 492 says that find the number of ways in which 12 identical coins can be distributed in 6 different purses if not more than 3 and not less than 1 coin goes in each purse. So it is equivalent to integral solution of x1 plus x2 plus x3 and so on till x6 is equal to 12, where xi is between 1 and 3. So number of solution, integral solution is coefficient of x to the power 12 in x plus x square plus x3 to the power 6. We take x out and we have got coefficient of x to the power 6 in 1 plus x plus x square to the power 6. Now after that it's a simple binomial equation for negative indexes, and we have answer as 141. Question 493 says that find the number of ways in which 30 coins of 1 rupee each be given to 6 persons so that none of them receive less than 4 rupees. So maximum a person can get is 10 rupee if others get a minimum of 4 rupees. So coefficient of x to the power 13, x to the power 4 plus x to the power 5 through x to the power 10 to the power 6. That is quotient of x to the power 6 in 1 minus x to the power 7 to the power 6 multiplied by 1 minus x to the power minus 6, that is 11c6 or 462. Question 494 says that find the number of ways of wearing 8 distinguishable rings on 5 fingers of right hand. So consider this case, we have 2 rings on 3 fingers and 2 rings on 1 finger. Where R represents the rings and the pipe represents the empty space. We have 8 different and 4 rings and 4 empty spaces, that is the same. Remember that we are wearing these in 5 fingers, right? This should be 5. Okay, so 4 empty spaces, alright? So 8 rings and 4 empty spaces. These pipes represent 4 empty spaces. So this can be arranged in 12 factorial by 4 factorial. We can move pipes in any way. Question 495 says that 15 identical balls have to be put in 5 different boxes. Each box can contain any number of balls. Find total number of ways of putting the balls into boxes so that each box contains at least 2 balls. So this is equivalent to x1 plus x2 plus x3 plus x4. x4 is missing. Plus x5 is equal to 15. So xi is greater than or equal to 2. Now we substitute y1 is equal to x1 minus 2, x1 plus 2 and x1 plus 2, y2 is equal to x2 plus 2 and so on. We get y1 plus y2 plus y3 plus y4 plus y5 is equal to 5. 10 gets subtracted where yi is greater than or equal to 0. The number of integral solutions of this equation is 9c4. Question 496 says that in how many ways can 3 blue, 4 red and 2 green balls be distributed in 4 distinct boxes? Balls of the same color are identical. So number of ways of distributing n identical objects into r different groups is n plus r minus 1 c r minus 1. So for blue balls it is 6c3, for red balls it is 7c3, and for red balls it is 5c3. So we multiply these, we get 7000 as the answer. Question 497 says that how many different ways can, in how many different ways can 15 candy bars be distributed to Tanya, Manya, Shashwat and Advik? If Tanya cannot have more than 5 candy bars and Manya must have at least 2, assume all candy bars to be alike. So first we give Manya 2 candy bars, which will leave us with 13 of those. Number of ways of distributing 13 candy bars among 4 people is 13c3, that is 560. These included the cases where Tanya gets more than 5. Let's calculate the cases where Tanya gets at least 6. In this case, we give 8 candy bars to Tanya and Manya, which will leave 7 of those. The number of ways to distribute 7 candy bars is 10c3, that is 120. So the answer is 560 minus 120, that is 440. Question 498 says that prove that the number of n-digit quaternary sequences whose digits are 0, 1, 2, 3, in which each of the digits 2 and 3 appear at least once is 4 to the power n minus 2 into 3 to the power n plus 2 to the power n. So total number of such sequences is 4 to the power n. Number of sequences where 2 does not appear is 3 to the power n, and same is the case when 3 does not appear. Again, it should be O. However, these cases where both do not appear, and those are 2 to the power n. So the answer is 4 to the power n minus 2 multiplied by 3 to the power n plus 2 to the power n. Question 499 says that Shivank has 15 ping pong balls, each uniquely numbered from 1 to 15. He also has a red box, a blue box and a green box. How many ways can Shivank place the 15 distinct balls into the 3 boxes so that no box is empty? Suppose now that Shivank has placed 5 ping pong balls in each box. How many ways can he choose 5 balls from these boxes so that he chooses at least 1 from each box? So number of cases of putting indistinguishable balls into R boxes is 3 to the power 15 minus 3C1 to the power 15 plus 3C2 into 1 to the power 15. You can choose in different ways, 311 or 221. There should be a comma, which are 5C3 multiplied by 5C1 multiplied by 5C1, that is 250 and 500. So for 311 it is 250 and 221 is 500. However, for the first case, there are three ways to choose the box from which three balls can be chosen. So it becomes 750, and for the second case, it is 1500. The total number of ways is 2250. Question 500 says that in how many ways we can place 9 different balls in 3 different boxes such that in every box at least 2 balls are placed. So number of ways of selecting boxes will remain constant, which is 3 factorial. So we have 3 different boxes. Okay, selecting should be 3C1. It should be 3. It should be 3. The balls are distributed in 5 to 2. Number of ways of selecting balls is 9C5 multiplied by 4C2 multiplied by 2C2, that is 378. The balls are distributed in 4 to 3 manner. We have 9C4, 5C2 and 3C3. So we add all this and we multiply it by 6. This should be 3. There is no way it will be 6. So final answer will be half of that. Okay, in 3 different boxes. Yep. First, I'm reading 501. This is the one. Yep. So 3 different boxes, selection should be 3C1. Okay. So with this, we come to the end of this set of problems. Now let's look at the website and the question answer forum. So the website is astavak.org. You can download books from links 2, 3 and 4. These are PDFs which will not contain date. So when you download, you should add the date to those files, and you can come to the website once in 15 days or a month to see if these have changed. If I change the PDF, the date will change, and you can download the updated copy. Now this is my question answer website where you can come and ask questions. So the tags you can use is algebra, calculus, trigonometry and probability, and math is also there, and geometry, coordinate geometry are also there. So make a login here and ask questions or answer somebody else's questions. So with this, I will end this video here. I hope that you are finding the videos useful and informative. So thanks a lot for watching the video, and we will meet again tomorrow with 10 more problems. There are not many problems left. 500 we have done. So next, the 3 more days and permutation and combination will be over. There are 525 questions in all. If you got any questions, you can come ahead and ask here. Okay, any questions, explanation, because YouTube is comment box is good, but it is not suitable for math, and I'm working on providing markdown help, so you should be able to ask question and answer those. So once again, thanks a lot for watching the video, and we will meet again tomorrow with 10 more problems. Till then, keep practicing and keep learning. Have a nice day. Enjoy.